Hello, everybody. Where's my
Hi,
chat?
Christopher.
Hi, Amanda. How are you
Good.
doing?
I'm good. How are you?
Same old, same old. Right. Mhm. Okay, let's start sharing. Let's see. Okay, good. And start. Okay. Do you guys see the slide? Just checking. Okay, good.
Yes, we do.
Hi, Leroy. How are you?
Good morning. I'm good. How are you?
Well, not bad. Thank you. Thank you. It's all getting better. Do you guys have any questions before we start? We have 2 more minutes. Anything? Is there a life on Mars? That's a good question. Okay. Silence it is. Hi, Rebecca. How are you? Good. Okay. Yeah, I'm fine as well. All right. Okay. So let's start. Today we are moving to chapter 3 of our textbook. Actually, I'm gonna get it if I can reach. All right. It's called perception. I call my lecture sensation and perception just because I see it's a little bit too sketchy to talk about perception without sensation. So that's the chapter that we are doing today. And that was the test that you were supposed to finish yesterday. The good thing is that this is actually a fun chapter, despite the fact that it has a bunch of physiology in it. And I actually like it. So I'm a little artistically oriented. So hopefully any one of you who is into arts or drawing or paintings might enjoy that as well. Let's start with the, I can move that, move, right. With some practicalities, I'll repeat that on Thursday because remember this class is not required. So by today, you were supposed to collect your data for experiment 1. From what I can tell, 17 people have done that. 1 person abandoned and 4 need to finish. And these 4 need to finish today. That is, the experiment will close actually at 2 a.m. If by Thursday, that is today, 4 people do not collect data, they will be the ones to be paired into two groups, regardless of the group they're in right now, because I can't put people who are compliant with the requirements with the ones who aren't. So the person who abandoned the experiment can go back and redo it. It's allowed. And the next point is participation points. Quite a few of you are doing well, but there are 4 students who have never done anything in 2 weeks. So those people should consider studying, getting some points. Like we said before, the activities will stay open until Monday, September 21st, 10 p.m. These are the activities for today's week, which is week 3. And one little uh, favor from me, if you are posting in your blog something that's textual, like you're writing about patient con, try not to attach a file, because it's just a few extra steps for me to download, to look it up, to close it. Just type in the stuff right into the blog. I mean, you can do it in your word processing program, but then cut and paste into the blog, because that will be a little faster for me. Also, to people to whom I wrote some comments is that, remember, you need to be doing a little bit more than 3 lines. That is, your blog should be at least 200 words or a little bit more. Some of the activities, just to remind you, don't carry any points, like the neuron structure, coloring exercise. This is just for you to have fun. Okay, we will. Hi, Justin. We will have a usual break in an hour. If you have any questions that are not related to the slide, hold on to these questions until the break. If you have something that is about what I'm talking right now, then absolutely raise your hand or unmute yourself and ask your question. Justin, do you have a question?
No, it's not about this. It's about the class time. It's just I was gonna ask you like, is it okay if I leave about like a little bit before 11 o'clock today? I know it's optional today because like I have another class from 11, so I kind of want to join that class because I usually balance your class and the other class. So
Yeah,
it's like Tuesday and Thursday. I'm gonna come Thursday anyways, so
it's not a
that's what I'm
problem,
saying.
Justin. It's not a problem. So do, attend as much as you can. If you're going to use
Yeah,
that as
no,
one of your exercises, it's not a
yeah,
problem.
I'm gonna stay here for a while, like an hour or so, like just a little before 11, and then just leave.
Okay, stay for a
Yeah.
while.
Okay.
No problem.
Thank you.
All right, good. So that's the practicalities. Let's move on to what we'll do today. So let's talk a little bit about sensation and perception. What I won't probably have time to talk is the visual search and the feature integration theory. That's the point at the bottom. If we have time, we'll have some fun with subliminal perception. That won't take us long. But mostly we will focus on sensation and perception, in particular in the ecological view, known as perception action from the textbook. It's just a different term for that. Maybe less so on the constructivist view, not just because we don't really have much time for that unless we spend some time doing that on Thursday. Okay. So again, just to remind you that I try not to be a stickler about the textbook, obviously, especially you guys, Verrazano students. Uh, you're good. I assume you can read, so you don't need me to go over some of the stuff unless it's something specific. If you have a question regarding your test or regarding the reading of the chapter, obviously, it would be a very appropriate time for you to ask that question either today or on Thursday. All right, so one thing that we haven't done and probably won't be doing in this class is learning, which is obviously very important for cognition, but it's just, again, it would be another couple of weeks of which we don't have. Now, we understand that learning is actually, this is the definition, a relatively permanent change in the behavior of the organism But it's not just a change in behavior, it's also a change in knowledge. Because remember that we are talking about one part of the trilogy of mind, which is knowledge, desire, and motivation. In this class, we are only concerned with knowledge. So we're interested in changes in knowledge. That would be a part of learning as well. And of course, what's important is that um, uh, we, or any organisms, animals, humans, we acquire new knowledge. And the reason why we want that, because we need to be able to integrate it with what we already know and sort of guide our actions through that. That's okay, people. Thank you for joining. If you're a little late, not a problem. So knowledge is important because it lies at the basement, a foundation of intelligent behavior, not just behavior, but intelligent behavior. So if we think about animals, it's reflexes and instincts. We have them too. We are born with a bunch of instincts. If you have ever seen a newborn or a relatively young baby, you can hold a baby by her or her arms and the baby will kind of walk. And that's a reflex. So a lot of animal species have reflexes and instincts, but not too many of them besides us actually have intelligent behavior. So classical conditioning, we talked about it before, works well with humans as with animals. But again, we're talking about intelligent behavior, the one that's beyond um, instincts and reflexes. So what we do in intelligent behavior, we also acquire knowledge about the world. And we need that because we need to know about ourselves, right? And we need to know about our environment. We have to kind of store this in memory, and we'll be spending 3 more weeks on memory, which is going to be October. We will have to integrate, we should be able to integrate this new knowledge with the knowledge that we already have. And finally, we need to be able to use this knowledge in action. That is, we can plan and execute our actions. That's the frontal lobe behavior. Remember Phineas Gage, those of you who have done that activity. And for things that are sort of higher cognitive functions, we should be able to, I think we are the only ones, as far as we can tell, that we can use language as a tool for thought and communication. Yes, our pets, our favorite dogs and cats communicate with us, but do they have language the way we understand it in humans and in children, for example? An interesting question. Okay, let's start with just a little bit of a history, which allows us to start thinking about the question of how we know the world, how we learn about the world. And there are sort of 3 main approaches. Again, most of that information you will be learning when you take Sci 352, History and Systems in Psychology. This is just a very small sliver of what is important for us. So Rene Descartes, let's get my color going. All right. Rene Descartes, 17th century philosopher from France, is the main representative of nativism. Also, he was the one who came up with the idea of dualism. Now, he actually was a devout Catholic, so he was not just a scientist, philosopher, but a deeply religious man. So, according to him, the body responds to sensory impressions. That is what comes through our sensory organs. And that in turn generates, so this experience generates behavior as reflexes. Okay, so the knowledge for Descartes is what is known as a posteriori, that comes after the experience. All right, but of course we have to say that the human mind has knowledge that is a priori. That's the opposite of a posteriori. That's something that is there in our minds, independent of our sensory experience. And for him, that a priori knowledge comes from God. And that's the dualism. So we have knowledge given to us by God, and we have knowledge that we acquire through our senses. Now, in contrast to Descartes, John Locke, who was a British philosopher, okay, was the empiricist. That is, for him, everything comes from the sensory experience that we engage in. It's either through sensation, when we observe certain objects, or through reflection, by which we observe the workings of our own mind. Okay, so, and that's actually the philosophical background of conditioning, either classical in the form of work of Ivan Pavlov, or instrumental in the form of work of B.F. Skinner. Interestingly, these two approaches competed for quite a long time until Immanuel Kant, who was a German philosopher, came sort of forward with the idea that the knowledge is acquired through experience, but our experience of the world also presupposes some innate component, some innate mental structures. So things that he specifically used as examples of innate knowledge is the knowledge of space and time. Just think about it for a second. I mean, how do we know that the time goes by? Now we have clocks. Let's put them all away. How do we know the time goes by? Yes, we have night and day, we have seasons. What do we know about space? How does this knowledge come to us? So Kant was the one who tried to bring the two approaches, nativism and empiricism, sort of together. All right, let's see if I can move to the next slide. Stop sharing, and let's do it again. All right. Oh, come on, thing. All right. So we'll start with that. We'll talk a little bit about the vocabulary, because it's very important, the distinction between distal and proximal stimulus. In this sort of the controversial dialogue between empiricism and nativism actually runs through the entire study of cognition. Now, of course, even Descartes, the dualist, would not deny the importance of sensory experience, right? We have to think about sensation. That's where we get our sensory experience as the fundamental of cognition. So we'll define both. So we'll think about sensation as a science that tells us about the presence of an object or an event in the environment. So basically, our sensory organs allow us to answer the question, is there something out there in the world? And also, it will allow us to make some judgments about how strong it is, or how big it is, or how bright it is, things like that. While perception is a little different. It's about mental representations of that object and an event. So here is the one of the main sort of tenets of modern cognitive psychology. That is the tenet of mental representation, where we infer mental representations of the objects, or memory traces, or percepts, or whatever it is in our mind, without really being able to physically test that. So the questions that we answer when we study perception about the objects or events is, where is it, for example? Is it doing anything? What is it? We have to categorize it, right? We need to know whether this particular animal is dangerous to us. And the two probably most important questions are, what can I do with that object? And the other side of that is what this object can do to me, right? So if you perceive some kind of shade coming out of the bushes, you need to know whether this is dangerous to you. Should you run? Should you flee? Should you fight? Okay. Now, this sort of distinction between sensation and perception is not quite clear, really. It's more like the way our bodies work with Canada and Mexico. We all kind of are North America. It's quite different from some other places in Europe. All right. So let's start with sensation first, the stuff in sort of teal green. And here the main distinction, like I already mentioned, is the distinction between distal stimulus and proximal stimulus. The distal stimulus is the object itself. So for example, on this slide, that's the tree. It can be rock, it can be ocean, it could be anything that exists in the world outside of our mind. Okay? While the proximal stimulus consists of the physical energies that emanate from the distal stimulus, and they fall on our sensory organs that are associated with our eyes, ears, and so on. So the proximal stimulus is a pattern of light waves if it's a visual stimulation, right? And that is the pattern of waves that is reflected off the tree, for example, in this picture. If it is sound, then it's going to be a sound that emanates from a particular object, and it falls in the form of a sound waves and falls on our ears, which is where this energy is registered. So what happens, the first step between distal and proximal stimulus is known as transduction. Transduction is the conversion of the proximal stimulus, that is the pattern of energy that falls on our sensory organs, to a neural impulse, right? So it has to be some kind of a interaction between the two. And what it's done through the sensory receptor organs. Again, we will only use vision as our example, but obviously you can read a lot about hearing and touch and other potential sensory modalities for which we don't have time in this class. So there are different receptor organs, in this case, perhaps the classical 5 that we'll talk about in a second, and they roughly correspond to these modalities in sensation, so vision, audition, olfaction, and so on and so forth. All right, so then the neural impulse is transmitted to the cerebral cortex of the brain. We talked about it last time. For example, we have a primary visual area in the occipital lobe, and that's where this neural impulse that travels through various neural pathways, in the case of vision, the optic nerve, becomes a percept. And that gives us a mental representation. So we start talking about perception now, because perception ends with this construction of mental representation of the distal stimulus. And it includes its physical features and perhaps the analysis of what it means, right? Is it a dangerous object, for example? Therefore, we have the main question. That's what sensation perception is all about. How do we get from the distal stimulus, the object, the event, through the proximal stimulus, the pattern of energy, to the mental representation of that distal stimulus, which we call percept? And that's what, again, this whole chapter is all about in its very sort of rudimentary form, because it's a very short chapter. In fact, many psychology departments have an additional course all by itself called Sensation and Perception. And we just don't have it on our books. And that's only here and maybe inside 232 where you will have a chance to learn a little bit about sensation and perception. All right, so let's start with sensation. Quickly. So that's a transformation of the physical energy that radiates from the stimulus, from the distal stimulus, into the neural impulses that travel through our nervous system. Okay, so it's a complex process. And we know from the work of 2000 and plus years back to Aristotle's time that he distinguished 5 senses: vision, audition, olfaction, gustation, and touch. And he wrote about them in his book called De Anima. And these are the classical 5 senses. That's where actually the idea of the 6th sense is coming from, because it is something that people talk about in pseudoscientific literature on parapsychology. Okay, before we go to this. So yes, we do have these different modalities. And they continue, although it's been 2,500 years since Aristotle, it continues to be popular in our culture. So here's my little digression from the strict science, is to show you this tapestry. Tapestry is a type of a rug that was woven in medieval times. It's actually 6-piece. I'm just showing you one. And this, it's in Paris. Actually, 6 tapestries are in Paris in the Museum of Medieval Art, and it's called The Lady and the Unicorn. So on the other 5 that I'm not showing here, you will see how the lady smells things, flowers, touches the tree, and so on and so forth, because people were fascinated with this idea of 5 sensory modalities. And actually, any of you who's a Harry Potter fan, you may remember that this tapestry is actually used in Hogwarts scenes where Harry and his friends attend school for so many years. Again, have a look at other potential representations of 5 sense in the history of our culture. So here's your activity number 1. The continuation of the tapestry tradition of the 5 senses through sort of allegories was picked up by some famous Dutch painters. And they created this genre of 5 senses in paintings. So I'm suggesting that you do some scavenger hunt on the internet, find who these Dutch painters were, which of the paintings on the 5 senses from these times survive to our days, and please do not forget to provide the actual links to the sites. Now, of course, 2,500 years did not come without some updating. And here is the approach to the sensory modalities that we have today. And they come from the work by Charles Sherrington, almost more than 100 years ago. So he distinguishes 9 sensory modalities or domains in which sensation occurs. Of course, they can be represented hierarchically, beginning with the division into exteroception, proprioception, and interoception. Now, exteroception refers to sensations that arise from the stimulation of sensory receptors located on the surface of the body, right? So as you can see, almost all the traditional Aristotelian senses are here. So we have vision, we have audition, we have gustation, olfaction. They are different in terms of how they operate, and touch. So these are the 5 Aristotelian sensory modalities. And there is 2 that Sherrington suggested should be also included, like temperature of thermal sensation and pain, nociception. Something that was not in Aristotelian classification is proprioception, that refers to sensations concerning the position and the motion of the body. So kinesthesis, and that's a sensation of the motion of the body. It's the stretching of the muscles, contractions of tendons, movements of joints, and that stimulates the nerve endings that are around those areas where this happens. Equilibrium is a vestibular sensation. It's gravitational force that pulls on crystals suspended in the liquid in semicircular canals. And it's sometimes classified as exteroception as well. So something that we are not talking about more than we have time for. And again, you'll see that there is an additional modality type that Sherrington suggested called interoception. And that is the modality that has to do with receiving stimulation from internal organs and tissues within our body, maybe our blood vessels. But the difference between exteroception, proprioception, and interoception is that we are rarely aware of interoception. I mean, how often can you say that you are detecting changes in your blood pressure versus can we see something? Can we touch something? So interoception is one of those relatively more mysterious sensory modalities. And that brings me to your potential activity, number 2 in week 3, where I'm asking you to investigate a potentially intriguing relationship between interoception and eating disorders. That is, do people who experience bulimia, for example, or anorexia, have something that's working differently for their interoception compared to people who don't have these conditions? Okay. So let's go through just a summary of the vocabulary for sensory modalities. So we have our proximal stimulus, that's the patterns of energy or energies that fall on our receptor organs. So let's say vision, that's what we'll talk about next. So we have the light waves that fall on our eyes. That changes through the process of transduction, right? That's a conversion of that physical stimulus into a neural impulse. And then through the sensory tract, in this case, optic nerve, right? The information goes into thalamus. We didn't talk about thalamus at all last time, but it's a structure buried deeply in the limbic system and surrounded by other organs like hypothalamus and hippocampi on both sides. And from that area, from that organ, from the thalamus, it then travels to what's known as projection area. And there we get our percept. So we travel. The information travels from proximal stimulus from distal stimulus into proximal stimulus into the percept in the projection area. So that's a little technical stuff, but because of the five senses that we will talk about, even 5 would be a lot. 9 is beyond what we could do. We will focus only on vision. But there's another reason why we want to focus on vision, why I would want to focus on vision. It's because 80% of our information in this world comes from vision. Everything else, all the other senses, 8 of them, if we take Sherrington's classification, only contribute 20%. So vision is the most important sensory modality. Here is a little depiction of the eye. Again, not that I'm going to ask you to think a lot about this, but just to get an idea, right? We have, I actually do a lot of work with vision because I do eye tracking in my research. So for me, it is critical to know a lot about it. In fact, my eye trackers, these the pieces of equipment that actually track people's eyes, critically depend on how the eye works. So we have cornea right here, and we have retina in the back. So when, let's say, when you read, you get the light waves reflect off the page of the book or screen and project to the retina. But the retina is actually quite large, as you can see that yellow thin layer of cells in the back, but only a small part of it, called fovea, just a little part, is actually where we can focus on a particular detail of the object. And obviously for letter recognition, it's critical. So anything that's sort of beyond fovea, to the right of fovea, forward on the page, or to the left of fovea, before that, is going to be blurred. We won't be able to see that well. And that's why we have eye movements. We do engage in eye movements because we want to reposition the eye, in this case, the fovea, well, the image that, the light waves that fall on the fovea, to the new section. And therefore our eye movements move with little fixations in between. And these moves are called saccades. It's a French word for jump, allowing us to focus on words. So if anybody is interested in something like, what is it called? Fast reading? No, it's not called fast reading. It's called something else. Anyway, if you are interested in learning how to read fast,
Speed reading. Speed reading.
yes, thank you, Leroy. Speed reading, you're right. So if you want to learn speed reading, that could be one of the topics that you could investigate on in your little blog to see whether it actually works and what it does. What do you need to do in order to maintain the balance between the speed of your reading and your comprehension, because that's where the problem lies. Retina has rods and cons. Rods are for details, cons are for color. Again, there are whole books written about this. I won't spend more than what I've just done now. And here is the optic nerve that leads from the eye into thalamus into Brodmann's area 17 in occipital lobe. Again, a big science for which there is not much that we can do. Interestingly, any of you who has a nearsightedness, perhaps lens, right? That's this piece in the eye, is the one that focuses the image on the retina, that focuses the image on the fovea as well. But there are certain conditions that can cause the eye to become slightly elongated. When I say slightly, you know, that depends on how you measure it. And then lens focus not on the retina itself, but slightly before it. And as a result, the images of the distant objects are kind of blurry. and hence the name. The name is myopia or nearsightedness. Unfortunately, these days, again, if somebody is interested in doing a little search on the internet about that, myopia or nearsightedness is extremely frequent these days. In fact, we can talk about pandemia or pandemic situation with nearsightedness in the world, and that's perhaps because of the way we read on our phones. We bring our phones close up. We develop over time nearsightedness. Okay. Again, not that I'm gonna spend any more time on that. This is from my favorite coloring book for the brain. If you are interested, do something like this. It's really, doing it with coloring. It's like doing it 3 times by listening. Finally, everything ends here in those little green areas. Okay, these are the projection areas in the occipital lobe. They are layered. In fact, people who've been studying the cells in the occipital lobe for vision have received a Nobel Prize for what they have done. There are many, many layers, many types of cells that respond to shape or length or the type of the object. Again, a very important area of research for people who do sensation and perception. Okay, let's move on to one of the sections in the textbook dedicated to an important school of thought from the 20th century, actually, called Gestalt. And Gestalt is a German word that is, I'm looking for the page for that. Let's see, where are we? It's page 50. That's Gestalt. Am I showing you the right stuff? Yes. And it's pronounced as Gestalt because in German, S and T, S before T is pronounced as Sh. All of these people were Germans, German psychologists. Many of them, if not all of them, had to immigrate from Germany in the 1930s, just before or during the time of Hitler, because most of them were Jewish, and so they were afraid of being prosecuted. Some of them are really well known, like Max Wertheimer, and they continued, and Wolfgang Köhler, they continued their work in the United States as faculty at different universities. So Gestalt, so like 1920s through 1930s. And this means about something like a whole configuration. That's a German word. My German is sort of mezzo, not great, but enough to know some of these words. Okay, so for them, the main idea, perhaps you've heard that, is that they focus on the tendency of the mind to organize the individual stimuli into groups or sets, okay? So they call it a perceptual whole. That's why the name Gestalt. Let's see. From their point of view, we cannot really separate our experience into components because components interact with each other, and therefore comes probably the most famous characterization of Gestalt psychology as the whole is different from the sum of its parts. And then, of course, they suggested several Gestalt laws, and these are laws of perception, right? Because it's all about how we perceive different objects when we can think of them as groups. So here is proximity. Now here we have, 13 dots, but we perceive them as groups as 3 groups of 5, 4, and 4 dots, just precisely because some of these dots lie closer to each other than others. Again, I encourage you to think about how we use Gestalt laws in everyday life. Here is the law of similarity. Things that share visual characteristics, shape, color, texture, whatever, are grouped together. So here we can see that those little diamonds are separate from those little, I don't know, what are they, dots, I guess. So we see this object as being comprised of 2 things, but each of them within itself is a figure. Here is a good continuation. We can look at A, and when a cable from A goes to this point, there are 2 possibilities. You can either continue sort of abruptly to the right, or you can continue smoothly, well, abruptly to the left, or you can continue smoothly to the right. And what we will do, using the law of good continuation, we will go right and assume that this is the cable A. All right, closure, not a very sharp picture. Here, as you can see, that here is an oval, and there's another oval in the third one. They don't seem to be finished. They don't seem to be complete because there is this white triangle. Although there is nothing that closes these 2 objects. These 3 objects, because these are 3 ellipses. Here is common fate. Okay, it looks like some of the birds are moving together to the left. The other birds seem to be moving together to the right. And so there are 2 new perceptual groups because of the common direction of the movement for these birds. Another one, these are all well-known laws of Gestalt psychology. So we see 5 circles here. We continue to see 5 circles here, although they are kind of broken. At this point, I'm suggesting, although this is not about Gestalt, but that's about extra sensory perception, is to do an activity that has to do with things that parapsychologists value, things like telepathy, clairvoyance, precognition, and psychokinesis, and see how these supposedly existing extrasensory perception processes are explained by magicians. And that's interesting. What time is it? 10:55. Okay, we still have more time. So one of the important approaches or conceptions or concepts in cognition is the concept of mental representation. Percept is a mental representation. Another one that is very critical for cognitive psychology is this distinction between bottom-up and top-down processes. So think about sensation as bottom-up, and think about perception as top-down, and we'll move on to perception next. So for bottom-up, we take the stimulus, the distal stimulus, and its environment, and we analyze it, getting into proximal stimulus and then the percept. So it's from the bottom, from the outside world into our brain, our central nervous system, moving up from details to more general understanding of the object. Now here, the only information that we can use, the information that comes from the object itself and from the environment that surrounds this object. In the bottom-down approach, it's different. Now we actually take the information from our memory, from something that we have already learned before. It could be our general world knowledge. We just happen to know that grass is green. It could be from our expectations, and we'll talk about that in a second. It's our contribution as a perceiver that makes sense. Now, we know that both of these processes are at play these days, but that's not how it is often considered in the history of sensation and perception, where sensation is more bottom up and perception perhaps is top down, or maybe both. And here is an illustration. So imagine that you have some kind of an object out there in the world, a tree. You get a pattern of light that enters the eye. In this case, maybe it's not a tree, maybe it's a sign, stop sign, right? You get this information, its shape, its color, red, its word stop in white, it's going up. We also happen to know how stop signs look like, and it doesn't really matter which country you're in. If you travel anywhere in the world, you will see it's a stop sign, exactly the same stop sign everywhere. So now we have these two streams of knowledge interacting with each other. We have the bottom up, the shape, the color, and we have the knowledge of traffic signs coming together. They give us the perception of a sign, in this case, the stop sign. So keep that in mind. We need to continue to think about top down and bottom up as we proceed through theories of perception, in addition to the classical theory of Gestalt psychology. Okay, so let's move on to perception, and that's really what this chapter in the textbook is about. Its sensation component is really, really small, while perception is much bigger. The one that I won't talk about at all is the Geon theory, mostly known as computational theory, because it's relatively well described in the textbook. So again, to remind you what perception is all about, where is the object? What is it? I mean, we want to classify it. Does it have a name? How do we use it? What does it usually do? What's its function? And again, the two most important questions are what it can do to us and what we can do to it. So that's what perception is about. I see a question from Noor, and the answer to that is phobia, and that's how it's spelled. Okay, to the next. So I continue to juxtapose sensation and perception. Now remember, the ultimate goal of perception is to create a mental representation of the object or the event based on a pattern of proximal stimulation. That is the pattern of light in case of vision, or a pattern of sound waves in case of audition, giving us final representation in the brain, going through two pathways that I hope you read about in chapter 3, the what and where pathways that allow us to answer the questions of where is it, what it is, and what it can do to us and what we can do to it. Okay, just to remind you, how do we get from stimulus to percept? We go through the stage of distal stimulus, proximal stimulus, then sensation transduction kind of chain, finally to the projections, or projection areas in the brain. Now we can use either Aristotle or we can use Sherrington, doesn't really matter. Like I said, it's only going to be about vision, just because it is difficult as is. Okay, so we will start with the ecological view of perception. The textbook calls it perception/action. I don't particularly like it, although, I mean, it's, like I said, this is just a synonym, and it's the same idea. So I will call it the ecological view of perception. But again, think about it as perception action in the textbook. This view was proposed by two psychologists at Cornell University. Unfortunately, none of them is alive anymore. Here is James Gibson and his Eleanor, or known as Jackie Gibson, his wife. The two of them created this idea that every stimulus provides all the information that's needed for perception. All right, so yes, Justin, fine. Anybody who can, who would like to type in chat, do you think that they follow the bottom up or the top down process in perception? I'm gonna give you a second. So if all we have bottom up, yes, very good. Yes, Rebecca, Karen, you're right, bottom up. Right, because they